GL2 and the evolution of Dee Sharpe's project. So I'm really excited about this one. Dee's one of our newest developers in the OS2 world, so please give your attention to Dee Sharpe.
Hello everyone, my name is Apollo Dee Sharpe, but I usually don't use the Apollo part. You know, I've never liked it, so I just go by Dee Sharpe. I'm 33 years old, and I stay in Copper Cove, Texas. I've been married for 11 years. I have 3 kids, and I'm currently a veteran of the United States Army. I just finished my time April this year.
Thank you.
Indeed. All right, GL2. The goals: to provide a framework for hardware-accelerated 3D support, provide an open source, non-encumbered video driver development kit for OS2 ecom stations, and to provide hardware-accelerated 3D drivers for OS2 ecom stations. Of course, I go through acronyms. Some of them are obvious, but a few of them are a little bit more technical. Some people won't know. Of course, everybody knows 2D, 3D. AGP Guard. Well, of course, the AGP system has the Guard interface, which is a graphics address remapping table. And it is basically a memory manager for video cards who don't have enough video memory space. So it allows the driver to take some of the main memory and allocate it and save it away from the rest of the system, basically. And of course, it does the same thing the hard drives do for virtual memory. Of course, everybody knows DLL and EDK. Does anybody not know about the grad system for video drivers?
I know it's there.
Let's hope. Well, that's pretty much all you really need to know. In case you don't know, OpenGL is a graphics library created by SGI back in the early 90s, based off of RxGL. And what makes this important is not just about video games, which of course I love, but there are some fields that need 3D graphics, and it needs to be hardware accelerated because 3D programming, 3D rendering is very CPU intensive. So of course they offload that to digital card, the video card. Where it comes into play is weather forecasting, medical imaging, and different scenarios like that, where our competitors have made inroads in and have gotten entrenched in, but we are lagging behind, and we can't get into those areas because we're still stuck with the basic IBM implementation, which is completely software-based. Now, what is GL2? GL2 is an interface that binds an OpenGL compatible library to the presentation manager. Because what exactly are you going to be able to do if you can't render to the windows or to the full screen? It is a provider of a rendering target for the compatibility library because you can actually render to anything. All you have to do basically is give OpenGL a buffer and it'll render to it. And it is a graphics device driver framework because we don't work for 3D graphics because we don't have a framework yet. Okay, of course, why? Well, because IBM never releases EDK. I mean, of course, it's out there, but a lot of stuff is out there. It doesn't mean you can use it legally. So the effect is, well, we need 3D graphics drivers, bottom line, and we need a DDK to allow us to facilitate the development of these drivers. And no, by the way, the DDK needs to be available. Anybody needs to be able to do it because you never know where a driver can come from. It can come from almost anywhere, but they need to have access, right? Okay. Also, because IBM's DDK is really old, it is targeted towards the earlier versions of OpenGL. Well, time has passed it by, and we're looking at OpenGL version 4 as the spec. However, there are no open source drivers that are there, but they get pretty close. They are in the 3 series with the Mesa guys, so we're not too far behind. And of course, Windows, Warpstock doesn't really care about it, so it's hard to reach some of the features of OpenGL, because all they care about is directory. So we're not a bad company if we could get at least OpenGL version 3. And of course it needs to be extended, because eventually OpenGL is going to go to the next level, the next level, the next level, and if we don't want to get stuck with an old rotation. Also, and this is highly subjective and highly based on your own preference, but I think that sometimes IPL's DBKs aren't the easiest to use in the world. And I guess and you know, to double tap on top of that, sometimes the techniques just kind of seem convoluted as far as when really what you're trying to do is move data around. It seems like sometimes you have to jump through too many hoops. You know? So of course, if it's hard for the developer to use the DBK, then there's a problem, because those are the guys who rely on the developers, right? So in effect, I believe we need a subsystem that's streamlined and purely focused for getting that data to the screen, and it needs to be relatively easy to use, because I mean, there are tons of systems out there, but if you can't use it, what good is it, right? So, in the spirit of code reusage and taking the best usage of resources, especially for what's basically a one-man operation, I have a list of ingredients that I'm using to put into this batch. And since my project has changed a little bit, and I've been slapped in the face with a little bit of reality, I basically went over and decided that the only bit of original code that I'm going to keep is my PGL layer, which in the system it is called usually OpenGL.dll, because usually there's a different library that would be OpenGL, but it's not named OpenGL, so if that makes any sense. And everybody does it like that. Windows does it like that also. So what's actually OpenGL in your system is not named OpenGL.dll, if that makes sense.
So isn't that a licensing thing? That they got to give it a different name because the other name is got to be licensed?
Well,
I'm not sure.
Yeah, for Mesa, but as far as the guys who have licensed it, I guess they named it OpenGL because it's an entry point to the whole OpenGL system. But what they're actually reading to is that binding layer that I was telling you about, and Windows is called WGL. But all that is the entry point. But that library also has references back to the original OpenGL function call. So it's a pass-along.
Yeah, it's a wrapper.
Yeah, exactly. It's a wrapper. But it wraps its window bindings on top of that. So it allows you to be able to tell the system exactly where stuff needs to be rendered, for the simple fact that OpenGL is a dumb renderer. So if you tell it to render somewhere, well, you're going to have to add the extra stuff like the offset of the window and all of that stuff, so that it's not just rendering based on the actual screen coordinates, but based on where that window is at, so it doesn't spill out and cover somebody else's.
Okay, so you're saying that the OpenGL library doesn't really define a presentation space.
Exactly.
So you actually have to wrap your own.
Right. And every operating system has to do that.
Yeah, usually most other libraries, they seem to start with presentation space and then you have to map theirs to yours. It's a little different with OpenGL.
Yeah, and it was actually done like that intentionally, because IrisGL, its forerunner, actually had all of that included, because it was heavily bound to the X windowing system. Mm-hmm. And what ended up happening is they realized that every time they come up with upgrade, they have to upgrade everything.
Okay.
So they decided to start cutting OpenGL up out of IrisGL.
Okay, so it was actually easier by moving the presentation space out.
Right.
Interesting. Okay.
So now you just tell it where to render, and it'll render that. You tell it to render on the moon, it'll probably render on the moon. And it doesn't care where you tell it to render it to, it just renders wherever. And
Just gotta give it the rocket.
exactly. You got to give it the rocket ship, basically.
Yeah.
Also, I'm going to try to make heavy use of Mesa because, it takes a lot of man hours to try to recreate an OpenGL library. And, that's a project of itself, which Brian has proven because he has a project. So why go and try to reinvent the wheel yet again when, like I said, it's basically just me. So to be smart, go back and slap my old plan in the face and throw it in the trash can because it really didn't make a lot of sense, to be honest. And of course, there's also an earlier port of Mesa to OS2, and the author was actually experimenting with using the grad interface to pass all of the information from rendering through a grad extension.
What's Mesa?
Mesa is Ryan Paul's OpenGL compatible library. But he tried to call it Mesa 3D for a while, but of course, Mesa GL for a while, but of course, like you said, copyright violations and whatnot. So they changed the name to Mesa 3D, and it doesn't matter. You can still call the DLL or whatever, but you can't license it as. You can't report it as being OpenGL implementation when legally.
This Mesa has no connection to the Mesa software that came bundled with Describe.
That's a spreadsheet.
Yeah.
Nor does it have any connection to
Yeah,
Mesa
that's
that you talk.
matter of fact, I think that's why the guy who originally ported Mesa to OS2 put Warp in front of it to try to distinguish it a little bit. And well, let's just be honest, sometimes we have name clashes, and I guess you just have to do your best to work through it as possible. And, how could Brian know?
Yeah.
But at the same time, he couldn't call it OpenGL, so I guess he had to call it something. So, moving right along, I'm also using some of the hooks from the Snap SDK because, like I say, the work is already done. Why go back and keep trying to over and over to reinvent what's already there with such limited resources? So specifically, the AGP driver hooks, because we really don't have AGP drivers. But since they already have the hooks for it, why not? Why the driver plug them into their hooks? They're already done. So you know that if you're using Snap framework, you have Snap drivers and all of that, then you know that those hooks will be used. Also, use their MGL library because, well, it's there. So use it, and along with their GL3D hooks. Because basically, they were working on this. I'm not sure how serious they were, how much resource they were putting in. It could have been just a divergence just to see if it could be done. But they were working on it. And so you can see the evidence in the EDK, SDK. The work was initially there. And it was a much older version of Mesa 3D. But why repeat the wheel? Follow on their work and try to update it. So how am I going to do this? How's this arrogant guy going to accomplish all of that when so many other people who knew better won't even attempt it? Well, I live under the philosophy that you've got to at least try. If nobody's going to do it, then you got to do it because no matter how bad it sucks, it has to get done, right? There are some of those moments where it just has to get done. So I broke it up into 3 phases. Initial bring up and verification to make sure that it works. The hardware transition, where you get the hardware drivers to come up on it. And it could really stop there, to be honest. But I would like to take what I call phase 3 complete integration. And I'll go over those in order. For the initial bring up and verification, of course, what's necessary is to make sure that you can get Mesa 3D up and running on OS2. Doesn't have to be accelerated. Just has to run. Just has to be run something.
The reality is you always need the unaccelerated software implementation anyhow, because otherwise you can't cover all hardware. There's always going to be some hardware you're not going to be able to accelerate.
True, exactly. So yeah, 2 birds with 1 stone, because you're going to always need that fallback just in case. Let's face it, there's really not a whole lot of 3D drivers out there. So even after one is created, and the second one is created, and the third one is created, we're still far behind the power curve. So exactly, we're going to need that. Secondly, attach the Mesa 3D to Snap via Snap's GL 3D hooks. Because like I said, they are there. Why not use them? Better men than me have created them, so sit on the shoulders of giants, right? Step 2, since it's time to move on the hardware, there are certain things that you need for hardware, especially if you have, for instance, an AGP card. Because the AGP is basically just a PCI bus, really, to be honest. But there are some extra benefits that comes with this implementation. Yes?
So I'm confused about how does AGP relate to the PCI Express cards?
It kind of really doesn't. PCI Express, you can consider it a better merging of the AGP system to the PCI system.
So is the AGP interface still like kind of logically present in the PCI Express, or are you basically saying this work is just going to work with AGP cards?
Well,
No, I don't think that's what he's saying.
Yeah, that's not what I'm saying. Well, basically what it works out to is, remember how I mentioned AGP has a guard? Well, PCI has a guard, but it's not really used as much.
I think they're one of the things where they're getting confused is they're thinking hardware. AGP is a protocol which is ported over PCI Express.
That's what I was trying to understand. Okay.
Now, what's not going to happen is you're not going to have AGP slots. They're gone.
Right,
Yeah.
that's what I wanted to make sure. We're not talking about old.
Right. Now, if we had an AGP card, and we have this will be able to use it because that's something different.
Yeah, okay.
Right.
Thank you.
Yeah. Unfortunately, we have a problem with acronyms. We're starting to run out of them, so we use the same acronyms.
Over and over and over. We got that pretty bad these days on Shakers and Street. Also, Gallium 3D, which is Mesa 3D's new hardware infrastructure, as far as being able to talk to the hardware, being able to organize the data efficiently.
Is that a logical organization, or are there actually chipsets that are supporting gallium interface?
Oh no, that's a logical. That is completely internal, and it's just the way they organize their work to make writing drivers a little easier. Because what they realize is that a lot of their drivers, they have to rewrite the same parts over and over and over and over, and they realize that, look, some of these things can be just cut out into its own separate piece.
Okay, so
And you write it once.
that's their equivalent of our grad, basically.
Exactly. And also, but since we have grad, we probably really need to use it. As much as I don't like it, it's there, and we probably need to use it.
And with
And
some luck, you'll be able to have a fairly simple mapping.
yeah, well, exactly. And grad also makes it easier to communicate to the video, the 2D video driver that is there, because that's the one that's going to have the resources. So you have to share with that driver. So grad allows us to go in there and ask it for stuff, which is wonderful, because the way this basically splits up is the Mesa guys have what's called DRI, a direct rendering infrastructure, which is more like a user space component. But then they have the DRM, which is the resource manager for it, which is a kernel space component. And so, how are we going to do this? Well, you can take that DRM and, of course, make it a grad extension. And you can talk to it by using the grad interface, the grad extension interface. So that makes it a little bit, that solves our problem that they already have a solution for in their world, but trying to make it fit in our world.
Yeah. From what you looked at so far, how different is the mapping? Or how difficult is the mapping to do? Is it coordinate space flipping, that sort of stuff, or is it just mostly argument?
Well, it's mostly just arguments and talking to the hardware itself, whereas we don't have some of the components, So it's just trying to make it fit, trying to shoehorn it together. But once we have that bridge, once I fit that into OpenGL, into OS2 structure of how to communicate with drivers, then everything should go just smoothly.
Yeah, well, it'll be interesting to see, because actually I think it's even more correct to say that now that we have Snap, we don't know we have something like this.
Well, yeah.
It may be there.
You're right.
Because like I said, I haven't looked at that code enough to know how complete 3D stuff is. I just know there's a bunch.
You're right. But in the essence of their implementation, at least they have the hooks for it.
Right.
And the calls in it as far as calling into the 3D library. And so even if they didn't complete the initial port of Mesa 3D, well, the version they were using was pretty old by now anyway.
Right.
So.
Yeah. No, I agree totally with you. My other point is that, we don't even know what the full API is. We know what's in the SDK, because that's what they exposed. But they may have actually had more that they weren't ready to expose until they had their own verification.
Exactly.
Yeah, we'll find out. It'll be interesting.
Oh, yeah. And of course, I mentioned DRM, the direct resource manager, device resource manager. And it is basically the kernel component of the driver. Right? And so we have to figure out how to make it talk to drivers the way our drivers talk to each other and talk to the model as well. And so basically that means I need a PDD. Right. So, well, since most of the work is done, then that means that basically I just have to have that interface, that underlying interface, to go through the kernel and talk to the provider. So that part is going to be fairly tricky, but once it's done, it's done.
Not even sure how much you need there. That's going to be, because you may find that you have everything you need in the current Snap PDDs.
Well, I just might.
I'm speculating.
Just might.
But you're right, you need a PDD component. Again, it's an unknown how much we have.
Exactly. And phase 3, complete integration. Well, the thing I learned about the gathering drivers is that they have what's called a state tracker. And the best part about the state tracker system is that you can have any kind of state tracker. They've been experimenting with a state tracker for Direct 3D. So, in essence, they'll be able to run Direct 3D programs natively. And you can have a state tracker for anything. The only thing a state tracker does, basically, is takes what you're sending it and spitting it out in a common format. So it's like taking a piece of ice and making a sculpture, and then taking a piece of coal and then making the same sculpture, and then taking some mud and then making the same sculpture. No matter what you feed it, it's still getting basically the same output. So it's kind of like a Rosetta Stone in a way, but you have to have the state tracker. And OpenGL is a state machine, so that's why they named it the state tracker. So basically, you just take that state machine, feed all that data out of the state machine, and convert it to what the drivers expect. And that keeps the driver API consistent, the internal driver API consistent. And so basically, once you create a new state machine, every driver that's already written automatically takes advantage of it. As a matter of fact, they also experiment with doing state machines for the X window system. So just to let you know, so in that particular circumstance, the hardware driver directly 3D accelerates X rendering, just basic X rendering, So why shouldn't we have it?
Yeah.
We're not any less deserving than those guys, right?
We have about 5 minutes to go.
Well, actually, on the last slide.
All right.
Are there any more questions?
Once we have this, which existing applications are going to be able to utilize this, and also which applications are we going to be able to bring over?
Well, the first part of that question is kind of tricky because since everybody knows that OS2 has strictly software rendering for OpenGL, well, nobody wants to write any OpenGL programs for it. And so that's going to be the hard part initially. But like I said, once we have it, we've now opened the door so people can at least port existing stuff over and begin to write new stuff. And like I mentioned before, I'm a big gamer, even though I don't really play games anymore. You're an adult, we have other things to do, Everybody would love to just sit down and do what they want to do, but, I'm still a gamer at heart. And I know that there are new generations of kids that are coming up and they expect certain things. Certain operating systems to them need to have certain things. It may be frivolous to us because the system works. We don't care about it working, correct? But the new generation, that's what they expect. And so the additional benefit is just one more feather in our cap to bring some of the new guys over. And like I was mentioning in another conversation, you know, those industries that we can't get into because of not having the full 3D support, we'll be able to slowly make inroads into it. And it was the same situation, if anybody knows about the operating system QNX. This was the same situation for the longest. You know, they were very heavy in the industry for embedded systems. But as everything started going 3D, there were some spots that they couldn't get into. So eventually they had to follow suit as well. And they did what they had to do. And it allowed them to extend their reach even largely. But at the same time, they were already the industry leader in their particular area. But that made it, I guess, a little bit harder for anybody else to catch up.
I know, they're really the first with usable peer networking on PC.
Yeah.
Very interesting box.
What's your background that you know how to do this stuff?
Well,
Army teacher or what?
No, actually, a lot of that stuff I learned years before I joined the Army. I started doing computers when I was 7.
No.
Even as far as designing what I thought was a reasonable computer. Some of my earlier drawings, when I go back to it, I say, hey, you know, I wasn't really that far off. And so, and I won't lie, I grew up very, very poor. And so, eventually, I came across a Commodore VIC manual and a Commodore 64 computer. Of course, years separate from each other. When I found the manual first, and years later I got the manual, and I started programming in BASIC. So all my programming experience is self-taught, and all my electronics experience is self-taught. So once I joined the Army, my job was actually doing missile maintenance. And so when they tried to teach me electronics, they couldn't because they didn't know what they were doing.
That's reassuring.
Break.
Well,
What's the manual?
These missiles are pointed where?
well, you know, the guys who created them are, you know, civilian companies.
Yeah.
And of course, you know, the Army is covering the maintenance of them.
Yeah.
Well, the problem is that most of the people in the military are taught from a book by a guy who was also taught from a book by a guy who was also taught from a book. Somewhere down the line, there was a guy who actually knew what he was doing, but the way the Army does things, it kind of photocopies and passes the photocopy on. So then they photocopy it and pass it on, and it just keeps going. So where initially somebody knew what they were doing, down the line, people are now doing it because they know it works. They can't tell you how it works. They didn't understand, for instance, the difference between hole theory and the electronics that they were teaching. They didn't have the principles, the foundation, is what I say. So I wouldn't allow them to try to teach me that way because I already knew it.
How did a young guy like you, we got a bunch of old goats. Yeah. How does a young guy like you get into OS2?
Well, during those days, my very, very poor days, I actually learned about a lot of different systems. And I'll remind you that I was in high school in the 90s, and I would always find out about these different operating systems, but I never could afford it. Well, fast forward a few years, and I joined the Army. And then eventually I go to, I believe it was Comp USA.
Yeah.
And hey, the operating system that I always wanted to try was sitting there and shrink wrap. So I grabbed it, you know, and I still got a copy of it, and I took it back to Redstone Arsenal in Huntsville, Alabama with me because I was still in training, and I started playing with it, and it was cool. And it had a little headset in it, and you talk to it, and you know, and look at what our competitors were doing. Look at what Redmond was doing. They couldn't touch it.
Yeah.
They really couldn't touch it, at least in my eyes. And since you guys are here, I'm assuming that you guys feel the same way, right?
They didn't think they needed to. It's not that they couldn't. You know, 'cause
Well, you're right, but you know, sometimes it's those little things, those wow factors and those, oh, hey, that's cool. You know, frivolous, of course, depending on your individual perspective, but you never know what somebody's gonna like, you know. And so I sat there and I did my 14 years, and after that time started winding down, I said, okay, well, what am I gonna do with the rest of my life? You know, there's so many things, and I've only known do this for 14 years. Okay, now it's like, okay, I can do any of all of this. What do? Well, hey, you know, I remember playing with OS2. Let's see if I can get that feeling again. And so that's what I did. But of course, the version that I had, the initial copy of War, well, let's just say it grew a little long in the tooth.
A little hard to install.
Yeah, very, very hard to install. And it didn't like hard drives in certain spaces. And even with the set of repurposed installation discs that came out, that 3-set, well, you know, sometimes it still didn't want to quite work. And also, that's the point where computers are starting to not have floppy drives anymore. So I just kind of, I just did what I could, and then when I showed up, you know, I didn't really expect people to care what I was doing, but I just needed an outlet to talk, and I needed to contact with other people and kind of share ideas a little bit, and that's where I popped up at. So the whole time, I had been at OS2 level, but during those 14 years in the Army standardized on Windows. So I had to have Windows, and it got to a point where, well, what are you going to use at home? Are you going to use Windows so you can take work home, as we all did in the Army? This is just one of those things you couldn't escape. Or are you going to use what you want to use, and you're going to have to fight with your documents trying to use them on Windows? So I've been here the whole time. It's just that I've kind of been aimed this direction because I had to follow the road that they needed me to follow. And so that's what I did. And now I'm following my own. No one. Well, of course I'm married and my wife's still working, and I'm a disabled vet. So
Not that you look that disabled.
Huh?
Not that you look all that disabled.
Oh yeah, I'm sure I don't. I'm sure I don't, but trust me, I am. And I will, as time goes on, look more and more like one. But yeah, I have situations. Well, it comes with the territory, so I'm not going to sit and cry about it, but you know, it is what it is. So I have a disability pension and I also get, as well as my wife still works. So, and of course, I'm trying to start a company now because I like everyone else, I like money. Who doesn't? Exactly. So.
Well, we have to move along to lunch.
Probably.
So thank you, Dee.